You train the model, loss went down, training finished without errors. You open the chat, type a prompt, and the response looks okay, but looks okay isn't engineering, that's vibes, and vibes don't survive production. Your first signal is the loss curve. Two numbers matter during training loss and validation loss. Training loss always goes down, the model is memorizing. But validation loss, that's the one that tells you if it's actually learning. Here's what looks like in practice. At Epoch 3, validation loss hits 1.45, that's your sweet spot. By Epoch 5, it's jumped to 1.78 while training loss keeps falling. The gap is growing. Your model is memorizing, not learning. Next up, perplexity. It answers one simple question: how surprised is the model by the correct answer? Lower perplexity means less surprise, which means better predictions. It's literally e to the power of your loss, but watch out for perplexity gotchas. Only compare on the same set. Perplexity on training data is meaningless, the model memorized it. And low perplexity doesn't automatically mean a good model. A model that memorizes your set scores great but is totally useless. Benchmarks give you standardized testing. Tools like let you run MMLU, human, and more against your fine-tuned model with a single command. But here's the thing, benchmarks can lie. Fine-tuning can inflate benchmark scores without improving real quality. If your training data overlaps with benchmark test data, or you specifically optimize for multiple choice format, you'll get great scores that mean nothing in production. Now for the vibe check, and I'm dead serious about this one. Create 20 to 30 prompts that represent your actual use case. Then run each through 3 models: the base model with a good system prompt, and your fine-tuned model. Score every response on 4 dimensions: relevance, accuracy, style, and completeness, each on a 1 to 5 scale. And here's the critical part: do it blind. Randomize which response came from which model. If you know which is yours, you'll unconsciously favor it. Let's talk about detecting the biggest risk in fine-tuning. Sign 1, memorized responses. If your model nails what's our return policy, but falls apart on how do returns work. It memorized exact phrasings instead of learning the concept. Sign 2, decreased diversity. Ask the same question 5 times with temperature 0.7. A healthy model gives varied responses. A model gives nearly identical ones. It's stuck in a narrow output distribution. Sign 3, catastrophic forgetting. Your model crushes your specific task but can't answer what is the capital of France anymore. Test with basic general knowledge questions. If they degrade, you've trained too hard. Fix it with less training, lower learning rate, or mixing in general data. For production models, human evaluation is the gold standard. Create 100 to 200 examples, get at least 3 people rating each one with a specific rubric, and calculate inter-annotator agreement. If evaluators disagree a lot, your rubric needs work. Can't afford human evaluators? Use LLM-as-Judge. Have GPT-4 rate responses on relevance, accuracy, and helpfulness. It correlates about 80% with human judgment, not perfect, but way better than nothing. Here's your evaluation playbook. Step 1, loss curves. Step 2, perplexity. Step 3, vibe check with blind comparison. Step 4, benchmarks. Step 5, task-specific human. Don't skip steps. Don't ship after step 1. Your users will thank you.